all have that math from last week, and I'm just going to go over the answers. Then I'm going to poll everybody and figure out which problems we should go over together. So you guys got it?
I do have it.
Okay, you had plenty of time to do that. Okay, so let's start with number 1. This is the one about the principal. The answer here was A. You guys had plenty of time while I was setting up. Answer number 1 is A. Number 2 is 45. 3 is 70. 4 is D. 5 has 2 answers. It's either B, which is 8.45 minus 8x minus 3.25x, or it is D, which is negative 11.25x plus 12.2 minus 3.75. Okay. Number 6 here, the answer is 1.375. They asked for it in decimal form, so if you put a fraction, that would not be counted. Number 7 here, this is the one about entering the value of C. The answer is negative 13.78. Number 8. Number 8 is talking about all the equivalents of negative 10/7. The answer here, there's 2 of them that you should have bubbled, which were D, which is negative 10 over negative 7, or negative 1 3/7. For number 9, the answer here is 4. Number 10, the answer here was 3.5 or 3.5. Number 11, this is the true-false question here. So the true-false is, the first one is true, second one false, third one false, the last one is true. If you came late, don't make noise. We're in process, okay? So it's true, false, false, true. And then number 12, the answer here is 14. Number 10. This is the one about peanuts and raisins. That was 3.5. The next one was true, false, false, true. Number 12 was 14. The one about David goes to the candy store, that's 14. David goes to the candy store is 14. David goes to the candy store is 14. Sarah buys a sweater. The answer here is 7.5. This is the electrician, and the answer here should be 3 answers. 6 hours and 270.
Yes.
8 hours and 360.
Yes.
9.5 hours and 427.5. The next question deals with triangle A and triangle B. This one here, the answer can be written as 21.75 or 21 3/4. I'm hearing a lot of people getting these right.
Yes.
Number 16, this is about Lisa who writes an expression, and it's asking where did she make a mistake. It's on B, which is step 1, where it's 3 parentheses 1 plus 2x minus 2 times the quantity x plus 1 plus 5. Number 17 is about a graph that shows the proportional relationship between number of hours that a factory is open. And this is a true-false answer. For this one, it should be false, true, true. You have to get all 3 of them. False that the factory uses 4 gallons of water. True that point W represents the number of gallons of water used. And true that the factory uses 9,000 gallons of water. Next one is number 18. There's a figure joining 2 rectangles. The answer here should have been 1,375. Okay. Number 19, which is Alfonso. This one, the answer here is B.
Yes.
B as in Bob. Okay. It's B as in Bob. Okay, number 20, this is about selecting all the tables that represent proportional relationships. This one, the answer is A. and D.
Yeah.
So the first answer and the fourth answer. Okay. And then number 21, the circumference of a circle. The answer here is 6.
Wait, hold, where are we?
The circumference of a circle is approximately 37.
I got 12. I got 12.
The answer here, the question is asking, what is the radius? That's half. That means from the edge of a circle to the middle. Not divided by 2. The diameter cuts from one end to the other end through the middle. Okay. I know that's a little tricky. So by definition. Number 22, this is talking about an inequality. And the answer.
On the little arrows, there's like tilde dot and tilde dot. Like, what's the difference?
I don't get.
Okay, let's talk about that for a second. So, I mean, it's like,
I don't remember it at all.
Can you explain what that whole like?
yeah, sure. So
Yeah.
when you're dealing with a number line here, okay, and you have a number here, let's say 5, and you're saying that x is equal to, or let's make it less than, equal to or less than 5. This means you fill in the circle and you draw the line out, okay? If it was a situation where x is greater than 5, you would not fill in the circle. So if it was this one, look at this format. It doesn't have the equal to. You would have an open circle and greater than 5. You see that?
What would the 5 be? Because it's like not including 5.
If it depends. Let me go back on this question since we have questions here. So it says drag the arrow onto the next line to represent the solution of this inequality. Let me write this up here. I'm not writing the answer. I was just giving you an example of how to recognize the notation here. So this one says 6x minus 4 is less than 8. Are you stretching?
No.
What do you?
I have something that could help people that I.
Let me explain it first, because I would like to make sure that they know what I want to get across before I let you do that. Okay. So the first things first, you want to isolate x. Okay. So you want to add 4 and add 4 on both sides. You'll have 6x, and then this will become 12. Then to isolate x, you want to divide by 6, divide by 6. This becomes x less than 2. Okay. So for this question here, if you were to put an arrow on the number line here, this number line looks like this. You've got 0, 1, and 2. And if it's less than, that's what it's going to be.
Like
That's what I did.
The open one.
But it has to be open circle. Open circle because it's not equal to.
Well,
Okay.
now I get it.
Now you get it.
Now I didn't know it had to be
I didn't get
open
it
and
close.
closed.
If it's not equal to, then you cannot fill the circle. Okay. Anna, did you want to add something different?
Yes.
Okay, what would you like to say? Okay.
If you every time you do it, you see inequality.
Try this marker, it might be better.
So it's always going to be pointing the way that is going. So say it's that way, then it's going this way. So it's going the other way, you go this way. So follow
Oh, you can do that, yeah.
Yeah.
I mean, that's possible, yeah. I'm glad I waited till the end because I wanted to make sure I solved this problem for everybody before adding that kind of memory technique. So, but do you guys understand now how that works? Okay. Good. So let's continue here. For number 23, the answer can be written as 6/35, 13/70, or any fraction in between 1/7 to 1/5.
Wait.
So those include 1/6.
Wait, is this the map?
This question is, the one about Maria claims that any fraction located between 1/5. Did I skip something?
Wait, hold on.
No,
I got 1.5.
there's one about Maria.
Run over 5.
Should we talk about this one?
Wait,
Yeah.
I didn't, I don't think I did.
Okay, let's talk about this. Let's talk about this for a second
Wait,
here.
1.5.
I got 1/5.
So let's talk about this for a second. I'm going to draw a number line here first. And what you have here is 0. Okay. And then oftentimes we usually think in whole numbers, but this question is asking us to think in fractions. And just to look at it, they're talking about 1/5, 1/7, and then 1/5. Okay, does anybody know why 1/7 comes before 1/5?
Because the bigger the denominator gets, the larger the number.
The smaller,
Smaller the
smaller the
number,
number.
but the larger the pieces are, like 7 words.
Right.
So smaller the pieces right
So
there.
the larger the denominator, the smaller the fraction. 1 divided by 7, just to help you guys, is equal to 0.148. And it keeps on going, and 1428. It's a really unfriendly number. I'm just going to write 143 because that's what 1428. 143. Has anybody memorized what 1/5 is?
20%.
Julia? 0.2. Yeah, that's right. So 0.2. And as you can see, it goes on and on, right? This question is saying that this person named Maria claims that any fraction in between 1/5 and 1/7 must have a denominator of 6.
No.
Is this true? It's
No.
not true. Okay, so this question says, what are some fractions that you could have between these two? You could have anything. Like that's why this is one where you could type in the answer and click it. But let me just show you how detailed you could be here. You could say 1/7. You could say 1/6.9, 1/6.8, 1/6.7, and it goes on and on and on and on. To the point where you are at 1/5.0001. Okay, you could put anything in there. Okay, do you see what I mean? You could put tons and tons and tons of numbers in there. Question there. 2/5 is 40%. That's too big.
I didn't,
Don't change the numerator. It's dealing with the denominator. So, yes.
So we're 1/5.5.
1/5.5 would be fine. I mean,
Yes.
because if you look at what I have it down to 5.0001, right? So my point here is that you could put any of those numbers in there and it would have proven it. They had other numbers here, like 6/35 or 13/70, but you could have done what I did here, which is like 1/6.9, or you could have said 1/6.8, right? But they were just saying anything that doesn't have 6 as the denominator by itself. So you can put other stuff in there. Okay. Number 24, you guys ready to talk about that one? Number 24 is a 2-part question.
Why you got this one?
Part A is 100, part B is 96.
I got it wrong.
Do you guys want to talk about this one?
yeah.
Okay, because I'm noticing early on, I just heard a lot of, yeah, we're getting it. But now, so we'll talk about these. And I'll go back to earlier stuff if people have questions, but I can feel that this is slowing us a little bit. So let's talk about this. All right, let me erase what I have on the board here. This is session 4. But first things first here. So company makes 2 sizes of boxes shaped like rectangular prisms. So the large one, we'll just go with the large, is equal to 16 inches tall, 10 inches wide, and 10 inches long. Before I proceed from here, I just want to make sure everyone knows when they talk about the height of it, that's what tall is. So I'm just going to write here H. Okay. Now it says that there's another box of this. There's a smaller one, okay, and the smaller one they drew it for us. So the small one is 4 height, 2 length, 2 width. Okay, does everyone agree with me here?
Oh.
Okay, let's not have the sarcasm like that. All right. So the question is asking how many of the small boxes can fit in. How many of you guys know the formula for volume? Okay, Yulia, what is it?
It's basically the base times the height, but there's have to be a width times the length.
Area of the base.
Area base.
Yeah, area times
No, I
height.
just-
Area times height, and I understand what you're saying now. Yeah, so volume is basically length, width, height. This is what she meant by
Yeah.
base. That's base. Okay, but let's call it length with height because we have 3 different items here. So for the big one, right, you really have 10 by 10 by 16. Okay, that's what you have. But the small one, you have 4, 2, 2. So I'll put it in here. 2, 2, 4. Does anybody know why I created this fraction here? Does anybody know why? Yes.
That's the area of the larger over the smaller?
It's the volume
Volume.
of the large, volume of the small. Okay. So if that's the case, you're going to figure out how many of the small ones fit into the large. Okay. So this one is 16 times 100, so 1600 right there. And this one here is 4 times 4, which is 16. So that means 100 small ones fit into the large. You guys see that? Let's turn that off.
Yeah.
That's social media, turn it off, okay? So this one here tells us that 100 small boxes fit into the large. Does everyone see how I did this? I divided the large box by the small, and I got 100. That means 100 small ones will go in there. Does everyone understand the math that I did here?
Yes.
Good, okay. So now the second question in part B says, the company plans to increase the width and length of a large box by 4 inches. So if we're increasing the large box by 4 inches, can I erase what I have up here? Does everyone understand this?
Yeah.
Okay. So if we increase it by 4, this becomes 20, 14, and 14, right? Yes.
Only says the width and length.
Oh, I'm sorry. Did I misread that? Yeah, just the width, not the height. So just keep this as 16 here. Thank you for that. And then it says to create a new, do you have a song that you want to sing for us?
No.
Did you have a song? Did you want to sing for us?
No.
Okay, I heard a song. Did you guys hear a song?
Yeah.
Why don't you come up and sing it here?
Yes.
Yes.
Why don't you come up and sing? I mean, I'd rather hear that than hear about that. I'd rather hear you. I'd rather play the role of Simon on America's Got Talent
Yes.
and then tell you
a buzzer.
and then hit the buzzer if I don't like it. You want to sing?
Yeah.
Okay, let's go back to this for a second. So 4 inches for length and width, and they want to find out how many more of the small boxes go in there. We're just going to do the same thing. So this is 14, 14, 16. Divided by 2, 2, and 4. So this is 2, 2, and 4. You guys see how I'm doing this? A lot of you guys look at this and you're like, oh, I gotta multiply 14 times 14. That's no fun, right? But you don't have to multiply because you're gonna divide this, right? So if you're gonna divide this, this is gonna come out to be 7, 7, and 4. So 49 times 4 is what you're gonna do. Someone tell me what 49 times 4 is.
196.
Yeah.
Is it 196? It's pretty good. Yeah, 196 is
And then
correct.
you minus.
And then it says how many more than the original. So you're subtracting the original 100, so it's 96. So that means 96 more than the original large box. So,
I got the
okay. But you guys understand this now, right?
Yeah.
It makes a lot of
I
sense.
solved it.
Okay, good. All right, great, great. Let's move on. I know that some of these are getting a little trickier. And if there were any from the earlier part, we can go over that. Sophia, you're okay?
Yeah. I'm fine.
Okay. So those were probably really tricky there. So this is talking about Lenny and the motorcycle. And the answer here should be 11,500.
Yes.
Does anybody need me to explain this one about the motorcycle?
Wait, That's what I believe.
So let me erase this here. You know, if he pays 11,000 and he bought it for 12.5%. So this means price plus price times 0.12 equals the new one, which is, well, they tell you this is equal to 14,375.
So you do.
So 14,375 is equal to P times 0.12. And you can figure out actual price without the tax by dividing this 0.12 by 0.12. Since you guys will have calculators on this and you do the math here, if you just said 1437.5 divided by 0.12, that gives you 11,979. Since you can have a calculator, 11,979 and change of 16 or 17 cents. That's how you would do it. The answer I gave you guys was 11,000. What happened here?
Because you didn't put the.
I missed the
5
0.5. That's what it was.
I was gonna correct you, but I didn't know what you were doing.
Okay, yeah, but let's do that again. So that's why it didn't come out right. But that should come out as 11.5. Okay. So you just divide 14,375 divided by 0.125, and it gives you 11.5. That's the best way to do that. Okay, let's continue here. The next one is talking about two maps. And the answer to this one here,
What am I doing?
the one about two maps, the answer is 144.
What?
Yeah.
The answer is 144.
That's what I got. I got 70.
It says determine the straight line distance. So you're trying to determine the distance from Gladville to Columbus. The thing about it is each centimeter, the question is asking, listen up guys, the question is asking in miles. You're dealing with inches here. You've got to convert the inches into miles, right? Is it centimeters or centimeters? You've got to convert the centimeters into miles, and they tell you what each centimeter is worth, and then you've got to convert that. Because right now you're probably just dealing with single-digit numbers between Gladville and Columbus, right? But you've got to convert that into miles. 1 centimeter equals 40 miles. So that's what they're doing right there.
Wait, so wouldn't it be like over 3 miles? I mean, over like 90 miles? 144. Oh, 144.
144.
1.44.
No, 144 miles from Gladville to Columbus. Yeah. So, all right, let's continue here. Let's go to the next one. This is about Johnny using a wheelbarrow. And this answer should be 42.
Yeah.
42.
I forgot to say that
What
one.
about 41?
I just.
Does anybody want me to talk about this
I just
here
didn't get it. I don't know.
a little bit? Let me get a show of hands. How many people? Show of hands. It's
I was
okay.
really tired.
Vandy, is that eyebrow like yes but no? Yes, but don't let anyone know.
No.
Okay. So this one is interesting. It's a volume question also. And it says that the volume of soil in the wheelbarrow, this is length, width, height again. 2 by 3 by 1.5. The truck is 11 by 8 by 6. If the truck is 70% full, right, how many wheelbarrows does he put in here? So what I would figure out here is what is 70% of the truck? Okay, so you have this is the volume of the truck, which is 11 by 8 by 6, right? And you want to fill 70% of this, so you multiply this by 0.7. You guys see how I did that?
Yeah.
So with a calculator, you have 11 by 8 by 6 times 70, which is 7. So this is equal to 369.6. Okay? So you need to divide that by the volume of the wheelbarrow. The volume of the wheelbarrow is equal to 2 by 3 by 1.5. So if I do the math there, that's 6 times 1.5, which I think is 9, right?
Yep.
2 times 3 times 1.5 is 9. So 369 divided by 6, 369.6 divided by 9 equals 41. So this is 41 and 06.
Well, I just rounded it.
Right. So that's,
You can't have 41.0.
so since you can't have that, they're going to round up because it's more than just 41 because there's 0.06. So you're going to put a little bit more in there. So that's why it came out to be 42.
Also, it says.
Does that make sense, Sophia? This was volume divided by volume again. Okay. Let's go to number 28. The answer here is C equals 10/3 G. All right. C equals 10/3 G.
Okay, I was confused for a second.
Oh, wait.
Yes, you
Wait,
That's the same thing. Three-
Yeah, I got it.
Oh, yes.
Yes, I got it.
Is that what you wrote?
Right, you got it, Mom.
Okay. Let's continue here to number 29. Sorry, cough is terrible, but number 29, there are 3 correct answers here. They are A, B, and D.
I got it.
Question?
I did too. I got A and C.
Give me 2 seconds here. I need to drink some water because I get a cough.
And X.
I got that too. Or Y.
Let's talk about
I got A.
it. So,
I got A.
so let me talk about this. Jan makes 4 of every 10. 4 out of 10. That's 40%. That's 0.4. Okay. So the ratio of shots that Jan makes to the number that she takes. This is A. 2 to 5. 2 to 5 is like saying 2 makes, 5 takes. It equals 0.4. Those are equivalent. Do you guys see that?
Yeah.
4 out of 10 is the same thing. It is an iced tea.
It's really good.
Lemonade iced tea.
Oh, really good.
I'm sorry, I've been like coughing all day.
Then don't you drink like herbal tea with honey?
I wish I had that with me, but I didn't have it. So let me go to the next one. The other answer says the ratio of shots Jan makes to the number of shots she does not make. So this is the 2 to 3 make.
I see. I read it. Oh, I see. Because 2 plus 3 is 5.
So
Good math.
right. So this means 2 to 3. But if you look at this, this is the same as saying
Yeah.
this because 2 plus 3 equals 5. So that one works. The last one that worked here was D. The equation is, this is D, 6.
It doesn't make sense.
If you reduce these two, where X is the number of shots she makes, and this is the number of shots.
It's gonna be 3.
Yeah, if you reduce this is 3X, and this is 2Z, this is the same as this. It's the same thing. This is,
Yeah, I thought
It's the other way around.
6Z.
X is the number of shots she makes.
X.
Well, let me fix this for you so you can see. Let me fix it for you. X is equal to makes, and Z is equal to
Takes. Misses.
does not make. This is miss, okay? When you look at proportion like this, you can rearrange it so that you have 2 over 3 is equal to z over x. Let me do that. Oh, I did that wrong.
Yeah.
Let me fix that. It's the other way around. 2 over 3 is equal to x over z. This is makes, this is miss. You guys see why I can do that though? Because I can divide both sides by z, divide both sides by 3. That's how I got 2 over 3 x over z. Yes,
I
Julia?
don't get why C is not.
Yeah, see.
Yeah, C is.
Let me go back to that one. Does everyone, well, before I do C, does everyone understand
Yeah.
A, B, and D?
Yeah.
No?
Yes.
Kind of get D.
Okay. Let me go back to C for a second
Oh,
to show
yeah.
you.
I
C, C is 4x equals 10y, okay? And it shows the relationship, x is the number of shots she makes, y is the number she takes. That's different. X is make, y is take.
Yeah, it should be switched around.
So let me just finish this for a second. Y is the number she takes. So if I divide both sides by 4, 4 is gonna, or no, I want to divide both sides by 10 first. So I divide by 10, divide by 10. I get 4 over 10 x equals y, then divide both sides by x. So I get 4/10 is equal to y over x. This is not correct because y is not about the number, y is supposed to be what she takes. She takes more than 10 shots. I mean, she takes more than 4. This should be make over take, but this is take over make. You see that, Yulia?
Oh.
Do you see why it turned out like this?
Oh, why should we flip this?
This should not be like this. This is currently saying take over make.
Oh, it should
Do
be
you
flipped.
see that?
Then
It
why
should be
should
the other way.
bottom?
That's why C is not the answer. Do you see that now?
Alright.
But the D that I did turns out correct when you reset the ratio. Okay. Let's talk about the next one, 30. This is about Mary and Jerry. Total distance in miles that Mary walks, it should be 2.25.
Huh?
2.25. How many people need an explanation?
This one.
Quinn, it's okay to say.
I got it.
Okay. Does anybody need an explanation on this? Sophia, Mary? I mean, Mandy. I said Mary because the question said Mary. No?
I
Well,
fell asleep.
you did?
I didn't do this one.
Okay, let's talk about this real quick. They're just asking about in miles, how many miles does she do? So she walks at a rate of 3 miles per hour. So her rate is equal to 3 miles per hour. Well, Jerry starts jogging at a rate of 4 miles per hour after she's been on the track for 15. Jerry jogs 2 miles as Mary continues walking, and they both stop at the same time. So we've got to deal with Jerry for a little bit here. So this is Mary, and this is rate of Jerry. Jerry is 4 miles per hour, and they both, after Mary has been walking 15. So the time for Mary is 15 plus something. So we got to figure that. Jerry walks 2 miles. So this is distance Jerry is 2 miles. When you look at this, do you know how to find Jerry's time? Go ahead.
You take his rate per hour and you divide in half because 2 miles would be 30 minutes.
Time is equal to distance
You can also
divided by
just
rate.
find the unit rate for that.
So this is 2 miles over 4 miles per hour.
Which is equal to 30 minutes.
Right. So this is equal to 30 minutes.
And then you add 15 plus 30 because
Right.
yeah.
So that's they both stop at the same time. So as a result, this person Mary, her time is right here, which is what they're asking about. This is Jerry's time, which we found out through that. Does that make more sense to you? Okay. Good. Okay.
Yeah, I did.
Okay, good.
I got it wrong.
Let's continue here. So this 15 plus 30, so. Well, they want the distance. So this is 45. So the distance for Mary, distance is equal to rate times time. So this is 45 minutes, and Mary's rate is 3 miles per hour. 45 minutes is 3/4 of an hour. So this is 3 times 3/4. So that's 9 divided by 4. 9 divided by 4 equals 2.25. That's Mary's distance. That's the answer. Okay. Okay. Let's continue here. Let's go to Marcus, number 31. The answer here is very interesting. The answer is not 100. So let's go here. The question is asking you, enter an inequality that shows the number of minutes Marcus can continue to add water to the pool without exceeding the maximum number. The answer is the following. 4,500 is greater than or equal to 1,500 plus 30M.
What?
How many of you guys got this one?
I got this.
Good. You got it, Ethan? Okay. Hannah, you want to explain to us how do we do it?
So I simplified, but I do have it written down.
Okay.
What you did is.
Do you want to come up here? Okay. Since you can do this one for us.
So what happened to you have in total? What's the problem again?
It's right here on the screen. You can see it.
Okay, so in total he has 450.
4,500.
4,500, and it says here that Marcus can continue to add water to the pool without exceeding the maximum, which means that it has to be greater than or equal to, because he can't.
Okay, I need your attention. All right. Okay, go ahead.
Because he can't go over the amount, otherwise he'll start to flow over.
Yeah.
And then you take. It says here that he's already done 150 gallons of water. Plus, he begins to add more water at a rate of 30 gallons per minute, which is, we already know that it's 30 per minute. But M would be, we need to know how many minutes he's going to do it for. So M equals the minutes that he's going to do.
Right. So if you guys didn't follow along, what Hannah did right here was very good. What we want to talk about is this. I drew this on purpose, just in case the equation didn't speak for itself. If the maximum this pool can handle is 4,500 gallons of water, and the pool already has 1,500, they're asking us to make an equation to figure out how much more water can be put in here with the 30 gallons per minute. This is the rate right here that the water is entering. That's why I drew this little faucet here, right? So what's happening is 30 gallons per minute are entering into this pool. And we know that there's already 1,500 here. This is like a number that sits here. It's called a constant. And it's sitting here because this is our starting point. We're not starting at 0, right? We're starting at 1,500. So what Hannah explained was we need to look at this rate because the number of minutes that you keep filling the pool is going to be multiplied by 30 because this is 30 gallons per minute. Does everyone see that? Not really?
I see it.
So what this means is you're starting at 1,500 and you just keep filling in the water at a rate of 30 gallons per minute. You could actually probably figure out how many minutes it's going to take to do that.
That's what I did.
Yeah,
But they didn't ask you for it. They just wanted an equation.
I think, but can't you just do like?
They're not asking you for the number of minutes though. That's the thing. The question is, what is the equation that you would use to find the minutes? So, okay, let's continue.
I got a different equation.
Okay.
Never mind.
What did you get? Do you want to share it?
4,500 minus 1,500
Divided by 30.
That's what I. Yeah.
Yeah, 4,500 minus 1,500 divided by
But
30.
if that is only telling you the number of minutes, but what they want to know is if you had the whole setup, because what you did is you already performed the subtraction, already performed the division. They don't want you to already do that. They want you to set it up like this so that it explains, because in the end, you're just going to find the actual number of minutes, well, from what you're doing there. They're not asking you to find the actual minutes. They're asking you to just set it up. Okay, so that's why it's different. I'm going to move on to the next one, to number 32. The answer here is they ask you to check off which ones are correct. And the ones that are correct here are A minus B is less than 0.
Yes.
A plus B equals 0.
Yay.
B minus C is less than 0.
Yes.
C minus A is greater than 0. A plus C is greater than
Yes.
0.
Yay.
Dylan, did you get to do this one or not?
Well,
You're chilling, laid back, like you're like about to fall asleep. Like you finished Thanksgiving dinner and you're about to fall asleep in front of a TV. Is that the situation? Okay, I'm gonna keep moving here. Number 33 is, this one is, this is kind of interesting. These are open-ended responses on this. It says, if Emily's school starts, can Emily make it to school on time without increasing her rate of speed?
Yes. Yes.
Emily, the answer is this. Emily can travel 3/4 of a mile in under 5 minutes. So she can travel 3 miles, which is 4 times as far, in under 20 minutes. This means that Emily will have traveled 3 miles before 8:45 a.m. And then there's only less than a half a mile remaining. And since that is less than 3/4 of a mile, she can do it.
Yeah.
So the answer is yes on that one. Does anybody want me to calculate this out, or you guys are okay?
I got yes.
I think you need a little bit more. I'm gonna keep going until. This is what I'm gonna do, Sophia. It looks like you have a lot of questions. I can answer. That's okay. We can talk about those a little bit later. My question before we move on from this packet is, were there earlier questions that people, I heard a lot of yays early, so I don't know if there are any questions before question, I think we didn't really hit anything until about number, let's see.
Wait, we'll look for if you answer with the number.
They don't want a number, they want an explanation.
So yes.
That would be,
Yes would be counted as right.
no, they want
I
explanation.
mean, yeah, just like yes because.
No, they wouldn't take a yes. They want an explanation. This is a 3-point question, and the explanation shows that you understand it. So a yes would not be sufficient on that one.
Well, but can you just like put your work thing, you don't have to you don't have to.
This question says, show or explain the words. You can probably show your calculation. Sorry. My throat is just killing me right now, but it says show or explain the work necessary to support your work. So showing calculations, fine, but they want explanation.
Can we go over number
Don't get
21?
caught on.
So I have that.
Let me get a 21. Let me get a 21. This is talking about circumference. Okay.
Yeah, that's not the one.
Is that the one you're talking about? Which one are you talking about? Oh, Alfonso.
That's ours.
That's number 9. Is it? Okay. Let's talk about Alfonso. Oh, did it? Okay, Alfonso is. Okay. This Alfonso says that he purchased a refrigerator and a stove. The sale of the refrigerator is 40% off, and the sale of the stove is 20% off. Which statement must be true to conclude that he received a 30% overall discount on this? So, there's a couple things. They're only giving you percentages, but they're not giving you actual prices, right? So we don't know the actual number, but we know that if this was, the first one's refrigerator, refrigerator times 0.6 plus the other one is the stove. Well, it was 0.8. Well, are they saying, well, they wanted a discount. Let me just go back to that because I was going to go to actual prices. But let's go to 0.4. And this is 0.2. Okay, they want to know that the total amount that he said that he paid was 0.3 off the total. Okay, so
I don't get how they got 0.3.
It's 30%.
How did they get 30%?
It's
the only way that this the only way that this could be true is if the prices are equal. Because let me just use this marker here. I'm just gonna, let's just, for the sake of it, plug in a number here and make it 100. So this is 100 times 0.4 plus 100 times 0.2 equals, this would equal 40. And this would equal 20. If you add them and then divide it by 2, you get 30.
Yeah.
Right? But if the numbers were totally different from each other, that would work, right? So that would verify that the prices were the same. But if this one was 400 and this is 100, right? It's not going to work because this is going to be 160 and this is going to be 20. And then if you add them up, divided by, it's going to be divided by 5. Well, should it be divided by 2, just to average it? This is not going to be, this is going to be 90, which would not work, right? So in that case, it wouldn't work, right? So they would have to have the same amount if we're dealing with percentages. Yes, Dylan. Yes. Okay. Any other math questions you wanted to go over? Let's pick these things up. Any other math questions you guys wanted to go over? Yes.
Can I go with the last one?
The last, okay, let's talk
You
about.
just explain it, it's good.
Sure.
Yeah.
You guys have something to add, or you guys have another conversation?
Oh, no, we were talking about, I was asking, what is the fourth dimension?
Okay, well, that's another topic.
No, exactly, that's the point.
So this is saying that the first thing you get here is, they give you times here, right? And they give you distances that she travels in a certain amount of time, right? So you know that within 4 minutes, right, from 8:25 to 8:29, she travels.
Oh,
What is that?
Her school doesn't even look like a school.
Well, so from 8, let's just go for time 1, which is 8:25. Time 2, this is 8:29 and 30 seconds. Okay, so this means that.
And I love how they're assuming that she's from America. Like, because the post office has an American flag.
Yeah, okay. Well, that just turns out to be what it is. But in that time period between 8:25 a.m. and 8:29, 4 minutes and 30 seconds, This is 4 minutes and 30 seconds that pass, okay? And she travels 3/4 of a mile. So the distance is 3/4 of a mile, okay? So you need to figure out what the rate is, okay? So her rate is that she can travel 3/4 of a mile in 4 minutes, 30 seconds. I know that looks yucky and ugly, but the question is really asking, how can she make it to class by 8:50 if it's 3 miles and 3.14 miles? So this was just to establish, here's your new distance. Distance to school is 3 miles and 42. Can she do this in an amount of what time? The time is from
8:25 to 8:50.
Yeah, to 8:50, so 25 minutes.
Yeah.
So really, that's what you're trying to figure out, is in 25 minutes, how far can she go?
Right.
This math here looks terrible, but we can fix this up to look cleaner here. Let me erase this first. So the question is, what distance can she travel at 3/4 of a mile for every 4 minutes and 30 seconds? Multiply that by 25 minutes. Okay? Do you see why I'm doing this, Miles?
No.
Because the formula for distance is rate times time. You see that? And we're trying to figure out, can she cover 3 miles and 42? So I'm going to try to multiply that. But I got to clean it up so everything looks the same. Right now you have minutes, 4 minutes and 30 seconds. So this is really, let's clean this one up to look like 4.5. Okay? 4.5 minutes. Okay. You have something really funny there?
Yeah.
Okay. So the easiest thing to do here is hold off on this 3/4, but this becomes 3/4, and this is 25 divided by 4.5. Since you are allowed to use a calculator on this thing, I think you're allowed to use a calculator.
Yeah.
Really?
It's going to be, let me just divide this. 25 divided by 4.5 equals 5.55. So this is 0.75 times 5.55. Okay? So this is her rate, 3/4 of a mile. For 3/4 of a mile, this is her time, right? So her rate, sorry, is this 3/4 of a mile for every 4.5 minutes. This is her time. So I've already divided this. 25 divided by 4.55 is 5.55. I'm going to multiply that by 0.75. So times 0.75 equals 4.16. 4.16 repeating. That tells me that in 25 minutes, on a regular, ride of her bicycle, she could travel 4 miles and 4.16 miles.
Right.
So that means she could definitely make it to school
Right,
in
yeah.
25 minutes.
We can go farther.
But as an answer, you're not just going to go, yeah. Because you know what? Yeah is like saying, hey, I know it's 50-50. Because if I say yes, yeah, maybe I'll get it right. No, maybe I'll get it right. They're not going to let you do that. They want you to explain the whole thing and why it works. Yeah.
There and worse.
Kind of see it differently.
No, can't you just put your
And I found how many miles she had left, and then it was more than 3.42. So
You said no, actually.
Yes.
Oh, you said yeah.
Yeah, I said yes.
Okay.
wait.
I did it differently.
Yes.
Can't you just put your work so no one will know you did it?
Yeah, but you should explain it, because if I just put numbers out there and
They just think you're copying.
if I just put numbers there and say, hey, you may not know what this is, but here's my numbers, then I'm going to tell you from a teacher's perspective, when students do that and they just write a bunch of numbers in there, like, yeah, you should be able to follow.
What if you label stuff?
If you don't label and don't explain, then it's just numbers. Well, they want you to, this is what I read to you earlier. What I read to you earlier is straight from SBAC. The way they wrote that was an explanation.
What?
The way that I read it to you, it was an explanation from SBAC. Okay, let's move on from math. We're gonna come back if you have more questions. I want you guys to take out this sheet right here. Okay? This sheet right here. It says possible strategies. Okay? You have it? You have it. Okay, don't mess around.
I don't think I have this.
You should have it in front of you.
Oh, it's good.
Yes, the things that I passed out. This is a strategy sheet here. And really, instead of just talking about a passage, I really want to get into what goes into doing reading comprehension. The reason why this is really important is because I think a lot of students, they just read the passage and they go to the questions and they read and it's like, oh, let me look at A. Does A look good? And they go to B. They go, does B sound better than A? And they go, maybe. Let me go to C. And they look at C and they're like, does C sound better than B? And does C sound better than A? Does this sound familiar to anybody here? I don't want you to do that, okay? Some of you guys are like, really? Why? And this is what I'm going to talk about. So let's talk about the strategies. You can see this on this page here. And there's some of these things that I want you to fill out here. So it should say, yeah, strategies. Okay, that's right. Shooting out strategies. So I want you guys to fill this out on the page on the left here, okay? You guys got that? So the first thing I want you guys to do here is to fill this in. When you read a passage, you should be reading critically. Now, I don't know if you guys know what that means, but reading the passage critically. So I want you to write that in for steps for reading comprehension. Read the passage critically. Number two, what that means is this, okay? Reading a passage critically means that you are identifying what the primary purpose of the passage is. Why did the author write this? What are the most important points that the author is trying to make? Quinn, I would write it down regardless of what Hannah is doing right there. So, okay, good. The second thing is to identify key points in the questions. Okay, when you look at a question, a lot of us look at these very loosely. They're kind of like, okay, do I get this question? What I really want you to do is look for key words and key points. Sometimes it's a word that they're asking about. They want you to go back to the passage to find it. Don't rely on pure memory, okay? Some students are like, nah, I got great memory, I'm cool, right? But I'm gonna tell you that the way that they rate these questions, usually there's a key word or phrase that they want you to identify. Yes?
So can you repeat what you're talking?
Number two or number one?
Number two.
Identify key points in the question. Identify key points in the question. Sometimes they'll give you a word in quotation marks, sometimes it won't be in quotation marks, okay? Sometimes it'll be saying something like the author infers something. Do you guys know what inferring means?
Yeah.
Okay, so it's not as obvious, it's a suggestion. The third one is find supporting evidence in the passage, okay? This is back to what I was saying earlier. A lot of students are kind of like, yeah, I got perfect memory, I'm photographic. I'm going to tell you, as much as you wish that you were photographic, the only way you could is if you could go to Best Buy and get a Google Glass, install it into your head so no one could see it, and then like take photos and have an SD card installed to the back of your head. No, that doesn't exist. I'm trying to tell you it doesn't exist. Find supporting evidence in the passage. So that means go back to the passage. What I'm trying to say is don't jump straight to the answer choices here. Okay, do not jump straight to the answer. So find supporting evidence in the passage. Number 4, make a prediction before looking at the answers. What is a prediction? It doesn't mean like, oh, the last one was a B, so this one can't be B, okay? That's not the prediction. Prediction is, hey, I looked at the passage. I understand what's going on, and I think this is what the answer would be in my own words, okay? Why do we do that? Some of you guys are like, oh, I don't need to do that. I'm going to tell you why. Because you don't want to be influenced by the answer choices. When there's 4 answer choices, 3 out of 4 are wrong. 75% of the answers are wrong. When a student goes, let me look at A, and they're kind of like, maybe it's A, let me look at B. Well, the problem here is you're comparing wrong versus wrong, okay? So when you start comparing wrong versus wrong, in your head, you're probably saying, which one sounds better? Well, the problem is 3 out of 4 of them are wrong, okay? So it's not about which one sounds better. So when you go back to the passage and you formulate an answer, what you are doing is you are establishing what is true and what is correct. So by the time you go to the answers for step 5, you are matching your prediction with the best answer. So that's step 5 there. Match your prediction with the best answer. Now, I know that sounds kind of different than what you usually do, but I'm emphasizing this because I don't want you to compare wrong versus wrong. Does everyone understand what I'm saying here? And some of you guys are taking it lightly. I know you're thinking it's the last day, but I think it's very important to know that as you progress, even past this examination for LOL, the SBAC, you will go to high school, you'll take the PSAT, you'll take the SAT, the ACT. Those tests are much harder, and this same strategy works on those. This is the same strategy I teach to people who are in high school when dealing with the SAT question.
Wait, is the first one match prediction to correct answer?
Yes, to best answer, to the best answer. Just do that. Okay. Okay, any questions? Yes?
What's the fifth one?
Match the prediction with the best answer. Okay?
But what if your prediction's right?
Then you won't find any match. That's a good question there, Sophia. You won't find anything. And you'll say to yourself, wait, none of these match. And so you've got to think for yourself, what really is the right answer? If you cannot come up with an answer, this is a good question that you asked, then you really have to go through a process of looking at each answer. But instead of just saying, is this better than the last one? Really what you should be saying when you look at each answer choice is just face value, yes or no or maybe, okay? Because when you hold on to, you're like, I don't know, let me look at the next one. I don't know, is it better than the previous one? You're comparing wrong versus wrong. You guys see what I'm saying? You should, in your mind, you should be thinking, of, can I say no to this? Because I'm going to say no to 3 out of 4 of them. You guys see it? Or if it's a 5-answer question, I'm going to say no to 4 out of 5.
What if you're comparing right to wrong? Not wrong to wrong, but right to wrong.
You mean you're sure of one and you're not, and you don't like the other one?
No, then pick the one that you're sure.
Yeah. No, I mean like you don't know which one's right, but you're comparing the right one to the wrong one.
If it's
Never
right,
mind.
Okay, Sophia, what you should be doing on that is you should be saying to yourself, I need to think of a reason to say yes to one of them, and I need to think of a reason to say no to the other one. What I'm trying to get you to do here is to be more confident in your answers rather than comparing A versus B, A versus C, A versus, don't do that, okay? I'm trying to take you guys away from that because most students do that, and this strategy is very, very useful, okay? Any questions? Any others? Okay. So Mandy, let's talk about this next part. There's, do you ever notice trends in the questions that you see on these tests? What are some of the trends you notice? Okay, so this is what I want to talk about. These test writers, they use the same wording in the questions and the answers. Sure, the topics are different in the passages, but the wording is very similar because there's a strategy to each type of question. Let's look at this next part, which talks about 6 classic types of questions.
5.
5? Okay. Wait. Is this it? Oh, it says 5. Okay. Oh, the pages are weird. Okay.
Is there one on the back?
Types of questions.
There's another.
Okay, never. Yeah, whatever. Okay, let's talk about this. So the first one here, when you look at this, there's something that's written right below it, right? Where it says, which evidence from the text best supports this statement? I'm going to call this a detail question. So I want you to write the word detail.
On the one.
Now the line, detail, just detail. What they're looking for, and the wording in this is very prototypical. They're really saying, can you find the important detail, the evidence, the support? Yes, Sophia. Yes, you can go to the restroom. Do you guys see that kind of wording there in the questions? This is very typical. I pulled these straight out of a test. And I looked at other ones, they had the same wording. The second one here, when you look at this example, Dylan, why don't you read these two sample questions for us?
The second one.
Yeah.
What is the theme of the text? Use details from the passage to support your answer. Select the two key details from the text and support the main idea.
So these questions here are asking about the overall main idea here. This is a main idea theme. Although we saw the phrase use details in both of these, really what they're trying to get at is the main idea or the theme. So on number 2, I want you to write main idea or theme. This is something that we need to establish when we read the passage. What I'm trying to train you guys to do here is identify the wording. Yes.
What was it again?
Main idea
Or theme.
or theme.
Or
Main idea or theme. Okay. Yulia, can you read the next one? Number 3, there's several examples here.
What influence can be made about Jim's feelings towards Father Time? Support your answer with details from the text. What does the word resorted suggest about Jim? Select 2 options. With which statement would the author most likely agree?
Great. So for these types of questions, do you guys sense here that the language is not as sure, it's not like as confident. It's saying what can be made about, what inference can be made, or what does it suggest? That's not a very strong language. It's like maybe we're just interpreting right here. But these questions here are inference and suggestion questions. The language is not as to just write inference or suggestion. They're asking us to make conclusions about what the author might agree with. None of us have talked to the author and said, hey, what do you think about Jim and Father Time, right? We haven't done that. So the only way we can do this is go back to the passage and look for supporting evidence that allows us to make that conclusion, okay? Hannah, did you have a question, or was that, I didn't see that?
oh no.
Mandy, don't put your finger in the socket. Okay. Let's go with Amelia. You want to read the samples for number 4?
How does the author's use of the phrase "spirits broke forth" help the reader understand Jim's experience in the country? What does the use of dialogue show about the relationship between Jim and Father Time? How does the author develop the relationship between Jim and Father Time?
Okay, what do you think the commonality is here with these types of questions here? What do you guys think?
Relationship. Talking a lot about.
Relationship?
What the author's saying?
It's just.
You're getting closer. The key word here is that the author either uses a phrase, uses a dialogue, or he's doing something with something. So these are what we call function questions, because he is using a word or phrase to communicate something. We're trying to figure out what is the function of that word, what is the function of the phrase. We should be writing this down just so you can.
Function question.
Function questions, okay? Because he's using something.
Words and phrases.
Yeah, or you could call it a use question if you want, if that's easier to remember, because what you're trying to figure out is how does the author use a word? How does the author use a phrase? So what I'm trying to get you guys to do is see familiarity in these types of questions so that it's just a routine. It doesn't matter what the topic is, you know how to tackle it. You know what words in the question to focus on, right? Use. Correct. So, Miles, you want to read the last one here, number 5?
Select the word that best defines motivated as it is used in a sentence.
Okay. This is called a vocab in context question. Vocabulary in context. Let's write 3 words. Vocabulary in context. The question is asking us how a word is defined, but it's not necessarily just the dictionary definition. It's how it's used in the passage. It's contextual. That's why it's called vocab in context. Okay. Does this change how we look at questions? Because I know a lot of students, when they do reading comprehension, they're kind of like, yeah, just throw it at me. Whatever it is, I'll answer it. It doesn't matter. I can handle it. Okay. I'm just reacting to it. I don't want you guys to be kind of like, if you ever seen somebody like throw a mouse into a maze and the mouse runs around and turns here, turns there. I want you guys to go with a strategy. That's why I'm talking about this, so that when you look at questions, you have something in mind and you're trying to answer it with a strategy. Okay. So let's turn. Any questions on that? Because these are questions. Yes.
I still don't get function.
A function.
You said you use the word use, but that's like.
It's like, how does he?
Not in the last sentence, so how would I find that?
This is like what is he using, or what tool is he doing, or what action is he doing to develop this relationship? It's kind of a function. That's why I categorize it more generally than just use. It doesn't have to be, but use is a trigger word for you. Okay. So let's turn this page, and on the back, you should have 5 spaces for classic wrong answers. And this is something else I want you guys to be very, very fluent with. Because a lot of students, like I said earlier, they just compare wrong answer versus wrong answer. They're kind of like, which one sounds better, right? There's this one, I kind of feel like this sounds better. The first one is the most obvious one. And a wrong answer is one, when you read it, you're like, was that even in the passage? Okay, so the wrong answer type is called never mentioned. Never mentioned. You read this answer, you're like, what? Where'd they get that from? That was never mentioned. Okay. A second one, which is really easy to spot, is an extreme answer choice. Okay. Now, some of you guys are like, what do you mean by extreme? Does extreme mean somebody who's like on punk music and like, yeah, this rocks so extreme? No. Okay. That is not what this is. Okay. I'm going to lose my voice from coughing if I do that again, but extreme in wrong answers is typically an answer that uses a word like always, never, totally, absolutely, never, any of those words. Does anybody understand why those words are extreme words?
What words? Oh my.
You'll have to wait till I'm finished with his water.
You said five words. Just write always or never.
Always, never, totally, extremely.
Jim will always.
Sorry. Does anybody know why those are extreme words? Anna?
Because rarely in these kinds of stories, they rarely write like Jim never bought a pair of pants, or Carrie always goes to the coffee store. Like, that doesn't make sense. It's just too
Extreme.
too vague.
Well, it's over exaggerated. What happens is this. Let me give you a scenario that you can relate to. If someone said to you, hey, do you watch this one TV show? What's a popular TV show?
Stranger Things. Yeah, let's go with that.
What's it called?
Stranger Things.
Stranger Things. And your friend says, yeah, I always watch Stranger Things. And then you said, did you watch it last night? And they're like, no. Okay. If someone said, I always watch this show, and then you ask them, did you watch it last night? They say, oh, I missed it. Do they really always watch this show? They do. So what I'm trying to, it's not a lie, it's an exaggeration. I know that a lot of, and I'm going to take a little tangent for 10 seconds here. A lot of people say, oh, I lied when they make a mistake. That's the wrong use of the word lied. Do you know why? The reason, when you say someone lies, they intentionally deceive with the evil intention. Okay? It's not a light word. It's not a light word. When someone lies in court,
You're trying to be evil
no, you're doing it because you are trying to cover the truth.
and be evil.
And it's typically done with bad intentions.
What if you're like trying to like you lie?
When someone says, if I said, oh, today is
like, oh, I do like
listen up. If I said today is Monday, and then a lot of people say, oh no, it's not Monday, I lied. That's wrong. I didn't lie. I wasn't intentionally trying to deceive. You guys see what I'm saying? So in slang, people say I lied all the
You
time.
can tell good lies. Like if someone's like really
Bad
obsessed
liar.
about their hamster dying or something, and like you know that
it's not going to be okay, but you tell them it's going to be okay.
That's not even categorized as a lie. You're just encouraging.
Or like,
people.
what if you say, I know he's going to.
Let me go back to the traditional definition. When you use words incorrectly, it doesn't sound intelligent. That's what I'm trying to tell you guys.
Right.
Your friends may say, "Oh, I lied." That's not correct. I'm just telling you. Everyone can be intelligent here. Okay, so going back to this, extreme language is language that is excessive with the intention to exaggerate, but it's not correct. That's extreme language. The next one, I'm sorry, that's number 2.
That's a lie.
Number three, okay, number 3 would be opposite. So the question may say something like, this character fights with Father Time in order to do which of the following, and if we give you a wrong answer that's totally opposite is to beg Father Time for more. To beg Father Time for more time or something. That was opposite because this person was laughing at Father Time, if you guys remember that.
Yes.
That would be opposite of it. Okay?
Or like he loves the city and never went out
Yes.
to go catch swallows.
Totally opposite, right? Yeah,
Yeah.
so he didn't love the city at all. He liked the countryside. So number 4 here, and these get a little trickier. It's an answer choice that you're looking at and you're like, hey, that looks like straight out of the passage. Looks good, but then you keep reading it like, the second part is weird. I don't know where they got that from. That's half right, half wrong. Half right, half wrong. When something is half wrong, it's totally wrong, okay? What that means is you're reading the first half of the sentence and it sounds like it's word for word, and then you read the second half and you're like, where did they get that from? You got to knock those out.
So what would be a good, like, other time?
It would be something like,
No, but then the banana walked in.
yeah, and it just brings in something that's completely irrelevant. So the next one, number 5,
Wait,
wrong
what would I
answer.
say for number 4? Like,
Number 4 is half wrong, half right. Half right, half wrong.
that's not half wrong.
But if it's only half wrong, it's totally wrong, okay?
Right.
The last one here, this is the trickiest one, guys, and I want you to write this down. The last one for number 5 is true, but irrelevant. True, but irrelevant. So they might ask you a question about this Father Time, but an answer choice might say something like, Jim likes to throw lassos, right? And you're like, yeah, that's true, but it doesn't matter, right? It doesn't matter that he likes to throw lassos or his dad taught him to do this. It doesn't matter. So these are tricky because you'll look at it and you're like, oh yeah, that's straight out of the passage. I get that, but it didn't really answer the question.
Right.
What I'm trying to train you guys is don't be tempted to circle something just because it looks like it's word for word. Make sure it is relevant and it truly is the answer. Okay?
What do you think?
Okay, so any questions about this? Because what I want to do is this. I want us to do a passage together and talk about it a little bit, and then we'll answer the questions together. So I want you guys to quietly read this passage here, which says, there is no I.
Oh, no.
Okay.
Actually, no, it's not. You need to look it up.
Okay.
I looked it up.
Hannah, what would you say on this one?
The summary.
A guy named Joshua Plotnick worked on a study where he did a test on elephants to see if they could cooperate to get an ear of corn. And he learned that elephants might understand that you have to work together to get something, and that sometimes there's more gain in two elephants or more working together than just one elephant working together.
Right. Well, the other thing, well, I'll let people add to this. Does anyone want to add? Both of these are very good here.
Yeah, well,
One other thing, what we're gonna add some more?
We're gonna try and use this on other animals and see if there are other ways that other animals cooperate that we don't know already.
All right. So how animals cooperate. Any others here who want to add to it? Was there any element of like discovery here? Let me ask that.
Oh, yeah.
Was there anything new that they realized through this? What do you think, Quinn? I haven't heard from you.
We learned, well, they learned that animals that can work together now.
That they can work together?
Yes,
Okay.
like elephants.
Okay.
It's new.
All right. Amelia, what do you think?
They learned that elephants can cooperate with each other to get food and
Why was it a surprise?
they didn't know that.
They've been testing for some reason.
Because most like the only animals,
Primitive.
What?
primates were the only animals that they found so far that could work.
Okay.
Good work, and they found out
Hannah?
that elephants.
This was shocking because they didn't realize that elephants could fully understand what cooperation was.
That's the good point there, because the scientists, they were trying to figure out, did they just learn a trick where you pull a string and get corn, or did they actually learn cooperation? And what these guys realize is, hey, these elephants are lining up, waiting, and another elephant comes along and ends up helping them. So they do have kind of some kind of communication, some cooperation where they work to get this done. So that's what they realized there. It's kind of subtle language here. Okay, let's go through some questions here. Let's go to number 1 here. Let's have Yulia read this one for us.
With which statement would the author most likely agree?
So when you see this, obviously they don't give you a specific word. Hey, do you need to sleep, Mandy? Okay. So they didn't give you a specific word to go back to or in the passage. So you've got to go with a yes, no. When you read these, Yulia, I want you to tell us yes or no before you read B, before you read C. So for A, yes or no. B, yes or no. Go ahead.
Learning about elephants can teach scientists about humans. Maybe, but probably not.
Okay.
B, learning about animal behavior is important for science. Yes.
Okay.
C, scientists should spend more time studying humans than animals.
That wasn't even mentioned in the thing.
D, scientists should study elephants in different ways than they currently do.
No.
It's not like he said this was a futile study. So the best one was, yeah, B. That's how we would do that.
Should we circle B?
Yes, let's do that. Let's go to number 2 here. Let's have, Sophia, you want to read it?
Sure.
Okay.
The author includes a description of a test that readers can try themselves. How does the author's example of using a book and a piece of string help the reader understand the research conducted by the scientist?
Okay, don't read the answers yet. Go back to where they talk about this test of using a string and tell us what the reader can understand.
Well, they can understand how the procedure of setting up the experiment and how it works.
Okay. Sure. What do you think,
It's
Moss?
about how you and your friend need to have cooperation. To
Yes,
get the book towards you
right,
without talking. You both bring it.
right. In the passage, There's a specific line. Did you guys see that? Did anybody go back to the passage?
Yeah, I did, but.
Yeah, right here it says, in other words, you and your friend must cooperate to get the book.
Yeah. So that's the key phrase. You and your friend must cooperate to get the book.
So it says,
So let's go back to the answers. Let's go with the yes, no on these here. So, Sophia, you want to read each one and give us a yes or no?
Okay. Not me, I will give you.
You don't want to do that? Kana, you want to do it? Give us a yes.
So-
Don't just give us the answer. Give us a yes, no.
A, it reproduces the scientist's experiment.
No.
Because it's not telling you about what they did with the elephants, it's
Mhm.
explaining a different experiment.
Okay.
B, it models cooperation without conversation. No.
No. Yeah.
That's kind of what it is doing. Yeah.
Yeah.
Right, that's exactly what that sentence said. Okay, next one. Next one.
It determines how mammals work together. I think that's not true.
Not necessarily. They were talking about primates.
Yeah, they weren't talking about mammals, they were talking about.
It analyzes the difference in human behavior.
Yeah.
That's not true, 'cause this isn't about human
They're different. So two things I want to
Well-
mention here. For C and D, these are classic wrong answers. Never mentioned. Never talked about mammals. Never talked about differences in human behavior. Never mentioned. You guys see that? Let's go to number 3. Quinn, you want to read 3 for us?
Read the excerpt from the text and the directions that follow. In other words, you and your friend must cooperate to get the book. In the case of elephants, they weren't motivated to get a book. Click the word that best defines motivated as it is used in the sentence.
What does that, before you look at the answers, what does the word motivated mean in this sentence?
Weren't interested and didn't want to do it.
Didn't want to?
They wanted to, motivation.
Oh, yeah.
Wanted to.
Yeah.
Motivation is wanting to do something, right?
But they weren't.
But they didn't want to. So weren't, I know it doesn't sound right to say weren't want to get the book, but it is kind of saying they just didn't want to get the book. What's the best answer you would go with on this one, Quinn?
Compelled.
Why compelled?
Because it's not persuaded.
You're just saying.
Yeah, no, because no one was persuading.
Let's talk about this. Let's open this up here. Amelia, what do you think about these words? Amelia, what do you think of these words?
Yeah. It wasn't influenced because there was like no one like changing like what they were thinking to do about it.
Okay.
It wasn't persuaded because also no one was like trying to like no one like yeah, no one was like
Don't
trying
know,
to-
like, you should do that.
So what does compel mean? Let me ask you guys, what does compel?
Forcing.
Compelled is forcing someone to do something. They weren't forcing the elephant.
He wanted to.
Compelled means
Wanted.
compelled means feeling the need to do something.
No, wouldn't it be persuaded? 'Cause you're like.
Persuaded means.
Oh, yeah.
Persuasion needs a third party to influence the elephants. Your best one here is compelled because you could feel, listen up real quick. When someone feels compelled, they are self-motivated. If I said to myself, I'm compelled to sleep early, I'm the one who tells myself that. I'm the one who goes to sleep early, right? If I'm persuaded to go to sleep early, that means somebody told me to do that. Or influenced me,
No
right?
one told him anything.
Right, exactly.
No one told
So we don't know.
the
Let's go to number 4 here. Mandy, you want to read number 4 for us?
So the answer was compelled?
It's compelled, yeah.
Yes.
I'd like to, otherwise it
Okay. So elephants understand the cooperation brings benefits to everyone involved. So it's a key details in the concept of what the main idea.
Okay, before we do that, this has the main idea. Rayhan, what's the main idea in that sentence?
Wait. The main idea is that elephants can cooperate.
Okay, and that it brings
Benefits to everybody.
Okay. So we need to find two things that show that they bring benefits to everyone involved. Let's go through each of these. Let's hear. Miles, you want to read the first one for us?
One will wait alone at the roof until another comes to help pull.
Is that benefit to everyone involved?
Yeah.
That's true. They both end up getting corn. Okay, so we'll save that one.
Yeah,
That could be one.
they cooperate.
Okay, let's go with Dylan. The next one, read that.
They give hugs and call each other by using their trunks.
No.
I don't know. First of all, I don't even know if that's true in the passage.
You didn't say that.
But that's not one of the benefits that they're talking about. Sophia, what about the third one?
The experiments like simple test sometimes it's a way to begin chlorine.
It's true, but it's not the answer.
They're not the ones
It's
that,
not irrelevant.
but they're kind of involved. Let's hold on to that one. Let's go to the, Yulia, what about the next one? Yeah, the next one.
Animals are so important only if both hold the rope ends at the same time.
Yeah, what do you think of that one?
No.
No.
No. It doesn't say
Yeah, I
elephant.
agree.
Doesn't say-
Show elephants understand that quote.
Animal.
That is true.
I think it's partly true. They
Partly.
get food out of it.
Oh.
Okay. What about the
Partly.
next one? What do you think of this?
Partly.
Let's hold on. We're gonna have a little vote
Part of
on
them.
what with F. What do you think of this one, Quinn?
Wait, where's the?
Oh, sorry, E.
Oh, two elephants can pull on rope ends at the same time to get corn close enough for both feet.
Yes,
Close enough?
Yay.
yes,
That's maybe.
Elephants can pull on rope end.
That's one of the things about
that is a
it.
yes.
Okay.
You say close
That's a
enough or just give it to
consideration.
them?
Yeah, we have to
That,
consider all of
that sounds better than E in the sense that D,
Hold on.
I mean, E is better than D, but
Yeah.
let's go to F, Hannah.
To figure out whether elephants can cooperate, Plotnick and Franz de Waal, comparative and psychologist at Emory University in Atlanta, built a test. Not relevant.
No.
I would say E works really well, and A is obvious because the one waits and the other cooperates with it. So we go with A and E on this one.
Yeah.
Okay.
He's right. I wouldn't have done.
Okay. What before you turn that over, guys, real quick, last thing I want to say here. If you notice this, number 4 was a main idea question. We talked about the types of questions. Number 3 was a vocabulary and context question, right? Number 4, this is more of a detailed question here.
Yeah.
Okay, and number 1 was more of an inference question. So you guys can see how what I brought up to you guys earlier is exemplified.
I know that.
Yeah, the strategy,
Yeah.
you use that on the test.
Can we use it on the test?
The sheet, you can't bring the sheet with you.
We can bring it with us.
No, you can't bring the sheet.
Can we write it on our arm? Can we write it on our arm?
I guess you can write it on your.
Yeah.
You can-
Stop cheating.
Okay, so last thing that I want to do here is do a little bit more advanced math here, guys. Yes. I want to do some, guys, listen up. We only have like 15 minutes here. So I want to talk about some advanced math here. So there's one more thing that I gave you guys here, which is our balance here. So you're going to do that. Okay. So, yeah, I mean, there's going to be a calculator on the test. So let's do this here. Let's go through these together. So we're going to talk, like I said,
Everybody
some
quiet.
of these
Everybody
topics,
quiet.
I can't even hear myself.
Guys,
think.
everybody quiet.
Okay, so. Yeah, this is how maybe we should have it. So let's look at number 1 here. Yulia already brought up something about the square roots, right? You're looking at. Okay, let's look at number 1 first. Raylan, you want to read number 1 for us?
Yeah, sure. Place each value at the correct position on the number.
So they got.
Oh, I found it. I know where to put it.
So how would you do this one first? How would you guys translate this one, which has a square root of 4 over 5?
Wait, square root of 4 is 2 over 5.
Right.
So it's 0.4.
How do you find the square root of
So let's talk about that for a half second. When you have square root of 4, you need to break down the number here so that it's 2 times 2. In order for you to take it out of this square root symbol, this is called a radical. The sign there is called a radical. In order for you to take it out, you need 2 of the same number. So this equals 2. So what Rehan was saying is this is actually 2 over 5, which is equal to 0.4. Okay? What about this one here? What do we do with it? This is pi over 5. What do we do with it?
Well,
It's like
3.14.
It's 3.1. No, it's 3.5.
3.14 over.
No, it'd be in between 60 and 70%.
So that's, tell us why you got that. That's correct. Tell me
Well,
why.
because if you just rounded 3 down, 3.14 to 3, 3 over 5, 3 over 5, 60%.
Good. So this is greater
Yeah,
than 6.6. That's exactly what I would have done. See, he memorized his fractions.
So and you have
This
to
is greater than 3/5.
round it down to the nearest whole number.
Well,
And
this
also
is
down depending on the number.
well, you know it's greater. It's this amount. This amount is 3.14 over 5 is greater than 0.6. You see that?
Yeah.
Because
Yeah.
3/5 is 0.6.
Yeah.
This one here, how do we convert 3/10?
It's just
It's just 3.
0.333. So this is equal to 0.33 repeating. Okay.
Yeah.
So now if we put this on a number line, the smallest of the 3 is this one.
Yeah.
The second one would be 0.4.
Yep.
And then it
Last
would
one,
be
yeah.
0.6. It's closer to 0.6.
Yeah. 0.6.
So this would be the smallest. This is the largest. This is the middle. Okay.
Yeah.
So that's how you would do that. Of course, you could plot this on the number line. You got.
Wait, 0.6.
Oh, this is closer to 0.6.
Well,
This is 0.4, and this is 0.3333. Okay.
Which is basically 0.4.
Oh, well, yeah, of course. That's the smallest of those 3 numbers. Let's go to number 2 here. Amelia, you want to read this?
Yeah. Oh, shoot.
Slow down. We're not there yet. Oh, we will be there in a second. We'll be there in 2 seconds. Listen, hear Amelia read that. I didn't hear it.
For each number, indicate whether it is rational or irrational.
Okay, so Quinn brought up the question, what is rational versus irrational?
Okay, I just.
Rayan, you want to tell us?
I think rational has like a whole number in it. It doesn't have.
Doesn't have to.
It-
Doesn't have
I
to.
forget what it means.
So I'm going to show
Wait,
you.
but like an
I'm gonna-
irrational number.
Slow down. Let me make it clear. So because Quinn asked the question, it's a vital question for this. I'm going to show you rational numbers here. Rational numbers have a predictable ending. Now you guys are like, what is that predictable ending? Well, Rayan said whole numbers. So yeah, 7, predictable ending. It ends at 7. You can call it 7.0, right? If I said 1.5, that's predictable ending. It ends there, and only thing that comes after that is a 0. It's a predictable ending.
Oh.
Do you see that? If it was 3/4, that equals 0.75. The ending is 5. So an irrational number is unpredictable, like pi. I know that when you guys first learned about pi, you guys learned that it goes forever. That's what you said, right, Miles?
Yeah.
So irrational
With a 3 point,
would be pi,
repeating.
which is 3 point, and it goes and goes and goes, right? That's irrational. Yes. So that's a good question. What Yulia is saying is, what if it has a lot of decimals? Like, for example, if I said 2/3, do you guys know what 2/3 equals? And it goes on, 0.66, and it goes and goes and goes. Do you guys think this is rational or irrational?
Rational.
This is rational. It's predictable.
Oh,
Because it's just gonna be 6 going on and on and on and
Like
on.
nothing,
Yeah.
unpredictable will be like
I love it.
92693.
Just random stuff,
Yeah.
random
Right.
stuff. So an example of irrational would be like 1/7. If you ever did this on a calculator, that's what we had there. So now let's go back to these numbers that they gave us. So we understand rational. Mandy, do you want to stop drumming? Okay, thank you.
You're not good. Stop.
So let's go back to these. Since you guys have calculators, what is 4/7 here?
And it says it's 4, whatever the answer.
It,
Approximately.
4 divided by 7. If you look at it on,
Something.
it just goes and goes. But if you look at it on your calculator, it's an unpredictable pattern. There's no pattern on that. Do you guys see that? So 4/7 is irrational. Okay, let's go to square root of 30.
Irrational. It's gonna be.
It doesn't need to be perfect
It's
square
gonna
root.
be 3
Let's-
times. It's like 5.4.
So this is square root of 30.
It's irrational.
And this one, if you look at it, if you broke this down, so some of us were asking about radicals. This is 6 times 5. It really doesn't break any further than this because this would be 2, 3, and 5. You can't take any of them out. So if you punch that into the calculator, that's probably going to give you the most definite answer on this. But if you said 30 and took the square root of it, does it go on unpredictably? Yes, it does.
Yeah, 5.4.
So this is irrational.
Oh my God.
It just keeps on going.
Okay. Okay, let's stop that, guys. Let's go to Quinn. What would you do with 21 over root 4?
It's rational. 4 is 2, and then 21 divided by 2 is 10.5, so
It's rational.
So correct. What Quinn said there is this is 10.5. And it ends at 5. It doesn't go beyond that. So this is rational. You guys see that?
What?
Okay, we already know the answer for pi, right? Irrational. The next one is
27 is rational.
correct. Why is it so?
Because
It's just negative 27.
Correct. It ends. Okay, good.
And
It is rational. Negative 27 is. So you guys learned something there, a rational, irrational there. Let's do another one. We only have a few minutes, so I want to maximize this math. Yes. The square root is when you have 2 of a kind. It's 4, 2 times 2. So the square root of 4 is 2 because you have 2 2s. You're gonna have 2 of the same number.
It's a number multiplied by itself equals the number that you.
It's like a number squared.
So, you have like
Square root of
81.
36 is 6.
What? Multiplied by itself equals 81.9, right?
Yeah.
That's your
It's a number squared.
Yeah. So let's
Okay.
let's go to number 3 here. Hannah, you want to read 3 for us?
Square with the side length S is an area of 324 square centimeters. This equation shows the area of the square.
So you just do 324.
What is the side length of the square in centimeters?
So how would we figure out S here? Since
Square
that's
root
what-
of 324.
Right. So we want the square root. So going back to square roots, this is what Miles was asking. How do we take the square root of something that's a big number like this? What would you do? Quinn?
I would see what it's not, like the biggest,
18.
Not big, like
18. 18.
Yeah.
I said it first.
No, regular answer.
Okay.
I said it first.
Nah.
Since there's no answer to it, they just leave it blank for us. I want to show you guys how to do this. You could do it by calculator, sure, but I want to show you. Imagine you didn't have a calculator and it was a regular everyday school test. Because your teachers aren't going to say, "Hey, everyone, pull your calculator."
Our teacher is very.
This is how I want you. I want you to see this for a second. When I look at 324, one of the things that I look at is how do I know if this is divisible by various numbers? First of all, it's an even number, so it's going to be divisible by even numbers, right? But do I really want to divide this by 2 multiple times and then divide by 2? That would take a long time. There's a rule that says that if a number, a big number, has the last 2 digits that are divisible by 4, then 324 is also divisible by 4. So if I did the math here, this would be 4 times 81. Do you guys see that?
Wait, what's up?
So
Oh,
this,
yeah, you don't see it.
because 4 times 1 is 4, 4 times 8 is 32. So 4 times 81.
So then what does that get?
So now we break this down. Look at this. And you've got 2 times 2 times 8 times 9 times
What?
10.
Oh, 2 times.
Oh, yeah.
Oh,
Okay.
times 9
Because
times-
9 times
yeah,
9 is
9 times
81.
9 is 81. and 2 times
So
81.
what Miles was asking is, how do you do radicals? If you got 2 of a kind, you've got 2 of a kind.
Got it. Okay.
So that means I pulled out a 2, I pulled out a 9. The answer is 18.
18.
You guys see that?
Because you pull one from each one. 2 times 9 is 18.
We know the answer is 18 times 18 equals 324. But what I'm trying to show you,
I get it now.
so let's go to number 4 here. Let's go to number 4. Dylan, read number.
Dylan, read number 4.
Read number
Number
4.
4, what's number
Hey,
4?
Ray.
Approximately 7.5 times 10 to the power of 5 gallons of water flow over a waterfall each second. There are 8.6 times 10 to the power of 4 seconds in 1 day. Select the approximate number of gallons of water that flow over the waterfall.
Okay, now this is kind of interesting here. This question is asking you, they're trying to figure out the approximate number of gallons. So Yulia,
Would this math be on the Sbac test?
it could be.
Why would they put it on
What
You're
is
so
your
smart.
So it is made by Sbac. So I'm just telling you that.
Oh my god.
So
Well,
let me just explain this real quick.
I'm
So
not going to love it.
7.5
Yeah.
times 10 to the 5th gallons per second. Okay. And the question says they are 8.6.
We're learning how to combine like terms.
That was like forever ago.
Yeah, exactly.
Oh, yeah, we're learning that right now.
Yeah.
So that's really
Seconds.
Learning what?
So do our school.
Guys, girls, listen up here. Listen up. I really want to show you something new, something different that you guys haven't learned. That's why I brought this math packet, because SBAC made this, and it may have topics. Yeah, it is. So let me explain this, because you guys are getting a little bit too rowdy for class. I know. So what you're dealing with here is select the approximate number of gallons that flow over the water in 1 day. Okay? This is the total number of seconds in a day. This is the total number of gallons per second. What they're asking us to do here, guys, I'm going to show you this, is multiply these 2 together. Because if I multiplied them, if I said 1 day is equal to 8.6 times 10 to the 4th gallons, and I multiply this by, in 1 day, right? Yeah. Okay. This is seconds. Okay, this is the number of seconds. Okay, in a day, they want to know how many gallons, but I don't need to write it. I can write it. I'm just going to multiply 8.6 times 7.5 times 10 to the 4th times 10 to the 5.
10 to the 4th.
So this is 10 to the 9th.
Yeah, 10 to the 9, that's how.
So you multiply 8.6 times
So what if the
7.5.
answer be 13?
8.6 times 7.5 equals 64.5. 64.5. When you look at the answers, none of them are written as 64.5. So you need to write it like they wrote it. The way that you do this is you move the decimal point to 6.45 times 10 to the 10th. To the 10th. Do you guys see why? Because I moved the decimal over, so I put a 0.
Yeah.
Yeah. So the answer is C, which is 10 to the 10th.
Oh,
Six-
I think I did.
6.4,
Wait,
10
what
to
was
the
the
10th.
answer to
Wait, why
30?
is it 10 to the 10?
18.
Because
I did
instead of
that,
writing
right?
64.5, you're moving the decimal point over.
Oh.
So it's gonna be 10 to the 10th.
Because the
Okay.
times 10 would bring it back to 60.
Okay, so we're not gonna get through the rest of this stuff, but what I wanna tell you guys is this. I brought this math because it's always good to challenge yourself with things that you haven't seen. That, I don't know, okay?
Yeah, we've learned more in this class like the 40s.
Oh, really? Thank
yeah.
you, Raymond, thank you, okay, thank you.
Yes, any day.
But what I wanna say is this, you guys, this is only the beginning. This is only, let me have your ears for just a few more seconds. This is just the beginning. And I know that all of you guys are very intelligent and are really hoping to go to the best high school you can go to. I want you guys to stay focused when you take these tests and know that, you know, whichever high school you go to, whether it's Lowell or any of the other ones, you will excel as much as you push yourself and motivate yourself. So today we learned that word compelled. Each of us should learn to compel ourselves, motivate ourselves, stay disciplined with it. Okay? Thank you guys very much. Stay in touch and good luck on the test. Thank you. Thank you. All right. Thank you. Okay, thank you. I'm glad that I know that I helped you more than what your teacher did at school.
She's really interesting teacher.
Thank you. I'm glad to know that that teacher. Thank you very much, Sylvia. Okay.
Bye-bye.
Okay. Thank you. Thank you. See you, Dylan.